Hi friends, Hossein is here. In this video, I'm going to talk about 8 database paradigms. What do I mean by paradigm here? In this context, each paradigm is actually a group of databases based on the way they store data and also their use cases. So these paradigms include key value, wide column, document-oriented, relational, graph, full-text search, multimodal, and time series. Even if you're already familiar with some of them, I encourage you to follow my narrative in this video as I try to address subtle differences between these paradigms. The first paradigm is key value database. The idea is very simple. It is using a dictionary data structure to map a collection of keys to a collection of values. We can start with a simple key like name, which is pointing to Hossein. Then we can make the key a bit more complex by adding some delimiters in between, name of a user with the idea of 100, which is pointing to Hossein again. And also consider that we can create a more generic key like user with the idea of 100, and it is pointing to a JSON object here. So the value is a bit more complex than the previous ones. Two popular options in this space are Redis and Memcached. Both of them are available on Docker Hub, and you can also search for cloud providers. The second paradigm is wide column database. This is still a kind of mapping structure, which is a little bit different than the previous one. In the key value database, we noticed that a value can be a JSON object. So searching on this object is not easy. If we just split these JSON properties into separate columns, then we can come up with a new data structure called a row. So each row has a key and a set of columns. Now searching is much easier because we can target each specific column. These databases are schema free, which means that each row can define its own column types, and the number of columns shouldn't be necessarily equal between rows. Two popular options here are Cassandra and Apache HBase. The third paradigm is relational database. This is actually the most popular and also the oldest paradigm in the list. So the main idea here is that we have these connected data sets that can have relationship together. If we just go back to the previous paradigm, we somehow created a kind of table structure in each row. The problem here is that these databases are schema free, so these tables can vary between rows. In the relational database, each table has a strict schema for itself and holds a set of dataset which is disconnected from the other tables. But we can define a kind of relationship between these two tables, for example, by defining two keys. One of them is called the primary key, which is targeting the main table, and the other one is called foreign key, which is targeting the second table. This way, we can aggregate data by joining the tables in different forms. Most popular options in this space are SQL Server, Oracle, MySQL, and PostgreSQL. The fourth paradigm is document-oriented databases. In this space, we have separate documents, and each document is a holder of a certain dataset. If we just go back to the previous paradigm, we separated datasets into separate tables. What if we want to keep all the information which is related to Hussein in one document instead of splitting it into several tables or sections. So then we can come up with a document one, for example, which holds a data set with the ID of 100, and it contains the user information plus the programming languages. So we can have another document for David, for example, containing the information related to David. MongoDB and CouchDB are two popular options in this space. The fifth paradigm is graph database. The main building blocks of graph databases are nodes and edges. Nodes are actually entities and edges are relationships between entities. These databases are very similar to relational databases. In the relational databases, relationships are just pointers. Here we are pointing the ID inside the users table to foreign key user ID in the programming languages table. What if this relationship holds data as well? So this is the main idea behind the graph databases. In this example, this man has a relationship with this woman, and the relationship is living with. And this man has a relationship with this car. So he drives the car, and this relationship also holds some data since 2011. The most popular options in this space are Neo4j and dgraph. The sixth paradigm is multi-model database. This is totally different from the previous paradigms that we reviewed. As soon as we upload our schema and data to a multi-model database like Funa, it is going to generate some indexes behind the scene. And then when we want to query the database, we should use a specific language called GraphQL. As soon as the GraphQL statement is sent to the database can automatically figure out what is the best paradigm to execute the query. So it can get benefit of the relational, document-oriented, or graph paradigms behind the scene to execute our query. Funa is the most popular option in this space at the moment. The seventh paradigm is full text search. So imagine that we want to create a search engine. What we do is that initially we enter some text documents to the database, and the database is going to use a stop word list to generate an index table. When the index table is ready, we can go through it and search for specific terms. Here, if we search for the term blue, we can see that it is referring to document 1 and 3, which means that the blue word can be found in these two documents. Most of these search engines or full text search databases are based on a project called Apache Lucene. Two popular options here are Elastic and Solar. And last but not least is time series database. Imagine that you want to insert data for stock prices or events coming from IoT sensors or even weather data. In these cases, we have to ingest huge amount of rows into the database in a continuous or streaming way. In this diagram, we have a comparison between Postgres and timescale in terms of ingest rate. Timescale is an extension on the top of PostgreSQL. So, considering the ingestion rate for Postgres, we can see that there is a threshold which is lower than 20,000 records per second. By using time scale, we can easily see that this threshold is going up and the average is about 120,000 rows per second. Time scale and InfluxDB are two popular options in this space. Thank you very much for your time and attention. If you liked the video, please subscribe to my channel and share it with your friends. Take care of you until the next one.